the last video, we talked about the greatest common factor between two numbers. Now I want to talk about something called factoring. Now, in algebra, in math, oftentimes we have inverse operations, right? Inverse operations are like, when I add, the opposite of addition is subtraction, right? When I multiply, the opposite of multiplication is division. When I square a number, the opposite of that is taking the square root, right? And there's more than just those, but those are some examples of inverse operations. Now, factoring is the inverse operation of distributing. So let's do an example. Let's distribute something and then see if we can undo that distribution, right? Do the opposite of distributing. So what if I have this? 3 times 5x plus 2. How would I distribute the 3 here? Well, I would take the 3 and I would do 3 times 5. And I would also do 3 times 2. Right? So we have 3 times 5 plus 3, let me make that orange, times 2. Oh, I think that should be the opposite, actually. 3 times 5x, plus 3 times 2. And that leaves me with 15x plus 6. Okay? That's distributing. Now, factoring is the opposite of that. So instead of multiplying something in, I'm trying to divide something out. Instead of, yeah, exactly. So how can I figure out what to factor out of 15x plus 6? Well, this comes back to the idea of finding the greatest common factor, right? What's the greatest common factor of 15x and 6? Well, remember in the last video we said, okay, I need to find the greatest common factor between 15 and 6. And then, well, x, I would find the greatest common factor between x and if there was any x's over here, but there's not. So x will just stay by itself. It won't be part of the greatest common factor. What divides both 15 and 6? What's the greatest common factor? Well, I know 3 divides both of those. 15 divided by 3 is 5. 6 divided by 3 is 2. 2 and 5 don't divide evenly. There's nothing that cancels out there. So the greatest common factor is 3. So then to factor that 3 out, again, it's almost like I'm undistributing a 3 from both of these. And so I'm taking the 3 out and changing the inside to 5x plus 2. I'm dividing 15x by 3 and getting 5x, and I'm dividing 6 by 3 and getting 2. So maybe another way you could think of it is I'm not changing the value of anything, right? I'm dividing this whole inside part by 3, and then I'm multiplying the outside part by 3 because the inverse of multiplication is division. So if I divide all this by 3 and then multiply it by 3, it doesn't change. Now the thing is, when I divide this by 3, 15x divided by 3 is 5x, and 6 divided by 3 is 2. So that would be how we factor out a 3. Okay, let's do an example where we don't know from the beginning what the answer is. How about this? What if I did something like this? 2x squared minus 4x. How about 2x cubed minus 4x squared? Cubed minus 4x squared. Okay, and I want you to factor this, right? Factor 2x cubed minus 4x squared. How could you do that? Well, I need to find the greatest common factor between 2x cubed and 4x squared. Okay, again, find the greatest common factor between 2 and 4 and x cubed and x squared. Well, the greatest number that divides both 2 and 4 is 2. Maybe we can do this in blue. I think that was a little more striking, okay? Or maybe orange. That kind of sticks with the theme. Okay, 2. The greatest common factor between x cubed and x squared. Well, how many x's do I have in common here? X cubed is x times x times x. X squared is x times x. So we've got 1, 2 here, 1, 2 here. So the greatest common factor between x cubed and x squared is x squared, right? 2 x's make up both of these. So then the GCF would be 2x squared. Now to factor that out, I need to divide both of these by 2x squared. Okay, so again, you could kind of think of it in pieces. Let's think about it this way. 2x cubed minus 4x squared divided by, we're dividing everything by 2x squared, and then we're multiplying by 2x squared so we don't change the value. Okay, 2x cubed divided by 2x squared. Well, 2 divided by 2 is 1, so those would cancel out. X cubed divided by x squared. Well, I guess I can't really do that. So let's write it here. 2x cubed divided by 2x squared. 2 divided by 2 is 1. X cubed divided by x squared, is x. Minus 4 divided by 2 is 2. X squared divided by x squared is 1. So 2x squared on the outside. And then just to fully kind of get us where we need to go, 1x is the same as x. 2 times 1 is 2. So this would be my final answer, 2x squared times x minus 2. So I factored out the greatest common factor, which is 2x squared. Right? When you do that, you're basically dividing everything by 2x squared and multiplying everything by 2x squared. And that gives you your final answer, right? We're taking a 2x squared. It's like I'm removing it. Rather than distributing it in, I'm factoring it out. I'm removing it from, when I take a 2x squared out of 2x cubed, I get x. When I take a 2x squared out of 4x squared, I get 2. So my final answer is 2x squared times x minus 2. Hope that helps. For me, it's always helpful to think of factoring as the opposite of distributing. So maybe that's helpful to you too. I hope it is. See you in the next video.